Hello, welcome to Code World. This is our videos. You can check them out and like, share, and subscribe. Now coming to the main topic. Today we will be learning about quicksort using doubly linked list. If you know what is quicksort, you can directly jump into the program part of the video, and the time of it will be given down in the description. Now coming to the quicksort. Quicksort, there are different types of quicksort. One in which the end element is kept as pivot, in which a starting element is kept as pivot, in which some random element is kept as pivot. So now coming to this, in this video we will be learning keeping the end element as the pivot and rest elements as the normal double linked list. Now I have taken three examples. The first examples in which all the beginning elements, starting elements are smaller than this number, and the later part of it are larger than this. And in this, all the starting elements are larger than this number, and all the second part of numbers are smaller than that number. And there is another example in which it's mixed, it's completely mixed, as you can see. Now coming to the first one. So in this, first we will be keeping a pointer here, and we'll keep another pointer here, and we will store this number somewhere. Let us consider it as x. So what we will do, we will compare this number with this stored value. Then we see it's not small. So it's small. That means that 10 is smaller than 20. So we will shift this pointer to here, and we will shift this one to here. This one comes here. Then we will check 5 with 20. It is also not small. Then this will be shifted here, and this pointer will be shifted here. Let's consider this pointer as I and this pointer as j. So I will be shifted here in first case, then j will be shifted here. Then in the next case, I will come here, j will come here. Then as this continues, so up to this continues. Then when j comes here and I comes here, j will be checked with this number. That means the 20 itself, like this number itself. Then it says, 25 is larger than 20. Then just j shifts. I remains here itself because it's large. Then when j shifts here, then again it checks. Then it finds that 21 is also larger. So I remains there. So until here we check that, and later after this we have to come out of the loop. Like this entire thing goes in a loop. After these things we have to come out of the loop. Then after coming out of loop we have to shift this I by one position. So I will be shifted here. That will be pointing to 25. Then this number 25 will be shifted here, and 20 will be shifted here. That means they will be swapped. Then what happens? Then this part is separated completely, So this part will be separated and this part will be separated. Example, what we will do is we will check 25 with 20, then 40 with 20, 80 with 20, 21 with 20. So when we check like this, we find that all these numbers are greater than 20. So in the beginning, j will be here and I will be here. So only j shifts till here, I remains here itself, because we can't increase I when the numbers are greater than the pivot elements. When j comes here, it checks with 20, it sees that, oh, 5 is less than 20. So in that case, I shifts here by one position, then 25 and 5 get swapped. Then j shifts. After swapping, j shifts here. Then it says 10 is also small. Then I shifts. I will be here. It's also shift by one position. I come here. I comes here. Then 40 and 10 gets swapped. Then 80 and 17 gets swapped. Then 21 and 15 gets swapped. Like this manner it gets swapped, and in the end, after swapping everything, we will be the position of I will be here, the position of j will be here, the position of j will be here. So now after, in this case, what you have to do? Jump out of the loop. After jumping out of the loop, we have to increase the I position by 1. Then here, instead of 25, instead of 5, 25 will be there as they will be swapped. Then 25 and 20 will be swapped, and then the remaining process will go on. I will explain what is the remaining process in the next example briefly. So now let me resolve. Now coming to this example. In this example, what happens is, as I said, they get changed. So the first step I am not explaining. The first step is after so I will be here, then j will be here, then j comes to 5. J like 20 checked with 5, it's greater, so I remains here itself. Then j comes forward, then 20 gets checked with 3, then 3 gets checked with 5, then it sees that 3 is smaller, then I shifts by one position, and this 20 and 3 gets swapped. So first, next j will be here and I will be here. J will be here. Let me write clearly. J will be here. I will be here. Then j gets shift by one position. So j will be here in this position. Like, let me write clearly. Then checks that 4 is smaller than 5. So I also get shifted and I comes here. So now I like at this condition 20 and 4 get swapped. So next step, don't mind the language, like the handwriting, it's bad, I know. Then coming to here, the j gets shifted here, so j and I remains here at present, so it will check 30 and 5. Oh, 30 is smaller, 30 is greater than 5, then I remains here itself. Here in the sense at present I is at 4 position, in this position, and j is here. We see that when j shifts here, then see that, oh, this is the pivot number, then it comes out of the loop, so it jumps out of the loop. Before jumping out, what happens? As you remember in earlier what I told, after jumping out of loop, what happens is I gets shifted by 1 position, so I will be here. Let me take another pen for better understanding. So I will be here, like I gets shifted by I plus plus, that is why I comes here, and as usual the last element and the I position element, that is 20, gets swapped. So what do we get here? Now what is the next step? This gets divided to 1 position, this is 1 and this is 1, these two become separate. Now let me take another color for better understanding. Now in this the next process goes on. So in this 4 is kept as pivot and this process goes on, and it sees that okay 3 is less than, so this remains there itself. Here it is, since it's a 2, only 2 elements, it looks easy, but in this case if it's 5 or 6 elements, then it will have to again go through that process, and again division takes place, and and here again it will keep 20 as pivot and check, okay, this is the element, so then this gets swapped. So like this, and instead of this, if there are 20, 30, 15 and 20, I am giving an example in this block. If there are 30, 13, 30, 15 and 20, what happens? J comes here, so at present J will be here, I will be here, then J gets shifted here and I remains there itself, because 30 is greater than 20. Then it sees that 15 is less than 20, then I get shifted here, then these both get swapped. When these both get swapped, it will be 15, 30 and 20. Then it comes out of loop, and after coming out of loop, here will be I, and here this is the last element, and these two both get swapped because the ith element and the last element get swapped. So it will be 15, 20 and 30, and then later this 15, okay, let me write it another, so it will be 15, 20 and 30. Then it will be divided like this, this is one part and this is one part. Since it's a single element, so no more process goes on, and 15, 20, this is sorted, this is sorted and this is sorted. I gave an example. Here in this case 20 and 30 get swapped, and it will be 3, 4, 5, 20 and 30. This is how the quick sort works. I think you understood. Now coming into the program part of it. Now coming to the main part, that is the coding part of it. In this, first we have to write the header, then using namespace std. So this is the basic thing. Now here I have created a class, so class node, and in public I am writing, so there will be one data field in double linked list, one next field that gives the address of next, and one previous thing that gives the address of previous node. Now what should I write next? Since this is a double linked list, I have to insert the elements, right? So to insert elements, so we have this void push. So what we'll be getting? So first we have to get the head, first thing, to push some elements. First we have to get what is head, then we have to get the data, that is the data we have to push. So we will be creating a temporary element. In temporary element using new node, then the data of it will be the data, and the previous, so previous of temp, temp of previous will be null. Okay, then temp of next will be head, because since I am inserting from to the front, so you can visualize it, so it will be the front. The node we create now, that is temp, the next node will be linked to head, and the previous node should be null. Now if the head is null, in case the head is null, then what should I do? Head of previous should be temp, then head equals to temp. Then what we will do? Head equals to temp. Then what should we write after this? This is done. Pushing the elements is done. We'll write the main, int main in last. Leave that at present. So after pushing the elements, what should we write? We have to think about that quick sort. So in quick sort, what should we do first? So in that quick sort, we will take only head, because it cannot give anything else, because the one thing which we can import from the function that we can ask to that main function is head. It can just give us head at present, so it gives us head. Then in this we are keeping the last node as pivot, so here we have to create a last node function that gives us the last node. Then this quick sort, I will explain what is this quick sort. Let me first complete this last node, then I will explain what is this quick sort. Okay, so last node, what we will be writing in last node? So in last node we import the head, as you can see here. After importing the head, this is not so important, this line, but for better clarity I have written this. So last, let's create a node variable last, in which the head will be given. Then let's see last, the last here, what is this? Last and last of next is not null, that's what we are checking. While last and last of next, what does this mean? This means that last is not null, that means this is not null, neither the next element is null. We are checking both. This is we are checking, because we are checking if the in first condition when it comes, is it null, we are checking for that condition, and this is for the last condition. I hope you understand. Then we keep on moving. Then when this condition in last, as I said, in this when this becomes null, we have to return the last. So this, now we have found the last element. Then quick sort head comma last. What is this? In this we have to now run a recursive function in which we will be giving the head and last, because as you seen, we will be keeping the middle element, then dividing the left and right, and this left will be again divided into two parts, then left and right, then again keeping the middle element, and again left and right, in the same case with right element. Then the whole process that combined, writing this code again and again, keeping on for loop, will be some tedious work. So what we will do is, we will keep a recursive function in which this function goes on. We write a single piece of code, this single piece of code executed again and again, then we get the result. Okay, now as I said, we have to write the recursive code. So this is the recursive code in which we are taking the head, and we are taking the last element. We are taking head and we are taking the last element. So first we are checking, is the last element equals to head? We have to check that condition because that is one of the important condition to be checked. And we are checking if the last is null. Then we have to check if the head not equals to L of next. What does this indicate? That L of next shouldn't be connected to head, right? It shouldn't be connected, right? Now coming to this. So what is this? Do you remember something in which we take the last element as the pivot and this function goes on, right? So who does this work? This partition function will do that work, and I will show what does the how to write the partition function. So partition function gives the pivot element. That's what P. It gives us the pivot element and helps us to divide. So in the partition elements, in the first case, the partition element gives us, in this case, partition element gives us 5 and 5. Then what should we do? Then we should divide this. What is this case? What is this? This is the previous of 5 and this is next of 5, right? So this from the head, the one left side, this is left side, so this is left side and this is right side. So left side and right side. So left side, what does this have? Left side, it starts from head and ends with the pivot, previous element of pivot, and in right side it starts with the next element of pivot up to the last element. Now coming to the partition part, what is the work? As I have explained you, first we should take x. So you know that head and last element should be imported. So in this, what is x? As I told, the last element, the information about last element. This contains the information about last element. Then I. What does this I do? So I, as I said, it's that thing which keeps on moving. Like the I in the beginning points here. I in the beginning points here. Then it keeps on moving, and if in case the element is small, it helps to swap. That is the work of I. So I at present will be previous of head element. That is basically null in the beginning. Then we create a for loop. In this for loop, that j as I shown here, j. What is j? The beginning element, and it keeps on moving based on the for loop. That is j, which points to h in the beginning. That it imports the elements of h in the beginning, like h. Then we should check that the j is not equals to last element, because it should stop before the last element, and we should move forward j by j of next. Then we have to check if j of data less than or equals to x, as we have checked here. If 10 less than 20, no, 10 is not less than 20, we keep on moving forward, right? In the same manner, here we check if g of data less than 20. In case if it's less than 20, so sorry 10 is less than 20, sorry, my bad. So 10 is less than 20, so what we do, we shift I, right? We shift I here, and at present j also will be here. So what will happen? The swapping takes place. Like here itself, self swap. This is nothing but self swap. This is we have to do this because some conditions it gets false. So in that case, we have to adjust with it. So j of data less than or equals to x. Yes, I will be move forward. How will I move forward? Here you can see I equals to this is an if condition. This is nothing but an if condition. If here it says this is a shorthand. If I equals to null, then take my I as h, that is head, or else I plus plus, that is I next. So after doing this, we have to swap the elements, as I said. In this case, in that case it was self swap, but in other case it won't be self swap. I will show what happens. So this condition moves on, that is I keeps on moving here, right, and the self swap goes in this case. So coming, and if you see in this case I keeps here itself, but j keeps on moving till here. But in this case I is here, j is here. So since it's not 20 is not smaller than 5, j comes here, that is to 3, and since in this case it's smaller, I comes here. In this case you can see this is not self swap, right? In this case I and j get swapped, that is 20 and 30 get swapped, and in this manner 320 this goes on. This is how it goes on. This this entirely says before that last element you should get sorted. The small element should come to left side and the large element should come to right side, except this last element. Then what should we do? We should put this last element to the middle, like we have here, as we exchange 5 and the middle element 20. So here the same condition we check, I equals to null. In that case I will not be null, right? So what will be happen? So I next will happen. Then we have to swap the last element. Here you can see h and I. As after this step and this step are not same, because here we are swapping I of data and last element, and as you can see this is not normal swap, right? I am sending and why am I sending and ampersand symbol? Because I am passing the address so that the original double linked list gets swapped. Then we have to return the pivot element. The pivot element will be nothing but the I. Now let's write this swap. As you can see, this swap is not an inbuilt function. We have to write the swap. So swap function in this we will be receive a and let's consider it as b. Then we'll create a int t which will be pointing to a. Then the swap a, b and b to t. You know the basic swap. Now the entire procedure is done. We have to write the main function. Now main function, this is just hard coded, this is just for your reference. So just we have hard coded. So push a520, this is that number have you as you can where that, as I explained here, 23, 4, 30 and 5. So those numbers, and here this is print list. I will show you the print list. We forgot to write that. We will write it now. Print list, and this is a quick sort in which we are passing the head element. A is nothing but a head element present right here. We are everywhere passing A. So then in last, after sorting, we will print the list. Now coming to quick sort, print list, or not quick sort, print list. So in print list, what we are doing, we are taking the head element, like we are checking up to the end, up to the null head. When head is null, we are saying, because head moves on. Here you can see how head moves on. Head equals to head of next. So before this we are printing the data of head. I guess you have completely understood the program. Now let's run the program. Now let's run the program. As you can see, linked list before sorting is 30, 3, 4 and 5, and after sorting it is 3, 4, 5, 20, 30. Quick sort using double linked list. Thank you for watching. Please do subscribe, like and share. You can check out many videos, like upcoming videos we will be putting many videos, like this is the life journey of youngest billionaire Ritesh Agarwal, like those motivational stories will be also coming up, and this algorithm series will also come up, and DSA series is however going on. Thank you for seeing. Thank you so much.